Hey guys, we're going to talk about solving equations again. If you haven't watched my previous videos on solving equations, I strongly recommend that because this is a little bit further and more advanced on this one. So we're specifically going to look at situations where we have to combine like terms and we have some distributing. So we're going to solve the following. Now, again, the focus on getting x alone. But if we look at this problem, this setup, right now I have 4x minus 7x plus 8 equals 20. If I look at the left side of this equals sign, things aren't exactly cleaned up yet. There's multiple x's there. I can condense that down before I even start to think about how I'm going to solve it and what piece to move. So I'm not going to draw my line down the middle quite just yet. What I want to do is I want to clean this up just a little bit. So I see like terms. Remember, some like terms are like when you see a 5x and a 2x. You can combine those and say, all right, add them together, that's 7x. If you see integers like 8 minus 3, you can combine those and say that is 5. So cleaning up what we can. So looking at this, I have 4x minus 7x, which is negative 3x. All I did is I took 4 minus 7, which is negative 3, still have the x hanging around. So I combine this 4x minus 7x, I get negative 3x, still have that plus 8 hanging out because I haven't touched that, still have the equals 20. So just like that, by combining like terms, now I'm starting to look like an equation that I've solved before. So again, the goal is to try and get x by itself, and to figure out what pieces need to be moved and when. We're still going to be working PEMDAS, the order of operations backwards. We're going to get rid of addition, subtraction first, then multiplication and division, then exponents, then parentheses. So I'm ready to draw my line in. I'm ready to work this equation out. We've got to get x by itself. Got to get rid of addition, subtraction first. So the opposite of plus 8 is a minus 8 to both sides. 8 minus 8 is 0, so on the left side I have a negative 3x. On the right side I have 20 minus 8, which is 12. Now I'm ready to work. This is multiplication here, negative 3 times x. The opposite of multiplying by negative 3 is dividing by negative 3 on both sides. When you multiply and divide by the same number there, a lot of kids like to say they cancel out, really divides to 1. So we have x. On the right side, we have 12 divided by negative 3, which is negative 4. So x equals negative 4. Going to hit you with another example here. We have 7x plus 2x minus 3 minus 7 equals 35. Again, let's look and check and see, is there anything I can do to clean this all up before I start solving? Are there like terms? So I'm looking on the left side. I'm seeing x is showing up twice. So I'm going to kind of condense this down. We're going to start one bit at a time. So let's do 7x plus 2x. So 7 plus 2 is 9. Still have that x hanging out. Don't forget that x. It's still with it. Have a minus 3 here. Have a minus 7 equals 35. I'm almost there. If you look, I also have some integers here that can combine. I have a negative. So you see I'm following the sign in front of it. Negative 3 minus 7. I can combine these two, negative 3 minus 7. Use a calculator if you need help there. You're going to get a negative 10. Still didn't touch that 9x, so I brought down the 9x. Negative 3 and negative 7 give me that negative 10. Still need that equals, still need that 35. Now that I've condensed it down, this is looking a lot better, a lot closer to things I have solved, so I'm going to draw that line in, start solving, doing that order of operations backwards. The opposite of subtracting 10 is adding 10 to both sides. Negative 10 plus 10 is 0, so on the left side I have a 9x. On the right side, 35 plus 10 is 45. Still have to solve for x there. Divide by 9. Divide by 9. X equals 5. Because 45 divided by 9 is 5. X equals 5. One last example I want to show you. On the back side, 7 parentheses 2x minus 1 parentheses equals 21. Now, I will tell you there are multiple ways about going about approaching this problem and solving it. Depending on how complex you get with solving equations, one of the methods doesn't work all the time. another method will work every single time. So I'm going to use and show you the method that works every single time. Anytime I see parentheses, I immediately want to get rid of them. Okay? So when I see a number out front like 7 and I see parentheses, I'm looking at this thinking, you know what? I think I want to distribute this. Get rid of the parentheses so we can solve. So I'm going to take this 7. We're going to multiply it all the way through this parentheses. So I'm going to take 7 times 2x. So 7 times 2 is 14. Don't forget your x. But I don't just multiply there. I got to take this 7 times the negative 1. 7 times negative 1. 7 times negative 1 is negative 7. I didn't touch the right side, which is equal to 21. So just like that, I had something that looked a little bit foreign to me, did some distributing, and cleaned it up. You should always probably distribute, clean up those parentheses, combine like terms. Once we have that, then I can draw in my line down the middle, and we're going to start solving this. We've got to get x by itself. So I'm going to start by order of operations backwards. Got to get rid of that minus 7, which means I'm on plus 7 on both sides. So I have 14x equals minus 7 plus 7 is 0. And on the right side, 21 plus 7 is 28. Almost there. When you see that 14x, that means 14 times x. The opposite of multiplying by 14 is dividing by 14 on each side. When you multiply and divide by 14, those divide to 1, so we just get an x. Again, most students, they'll say they cancel there. That's fine. On the right side, 28 divided by 14, that is 2. So we get x equals 2. Moral of the story here is before you draw on that line to start solving, always look and see if you could combine like terms, whether that be the x's, your variables, or your integers like negative 3 and negative 7. If you see parentheses, I would go ahead and distribute there and then solve from there after combining like terms. So that was solving equations, dealing with combining like terms and distributing.